During World War II, the world faced shortages of almost everything: steel, rubber, fuel, and even protection. Yet, in the middle of that chaos, a little-known discovery changed how soldiers fortified their defences. It wasn't a new type of armour, nor a secret metal alloy hidden in a lab. It was paint, yes, ordinary paint, enhanced with a chemical additive that turned wood into a bullet-resistant barrier. This wasn't science fiction. It was wartime innovation at its most desperate and ingenious. And the story behind it reveals how necessity and creativity often walk hand in hand on the battlefield. Let's dig into how Allied engineers found a way to make humble wooden structures, like crates, vehicles, and even sentry posts, resist bullets, using a paint additive that was both cheap and widely available. This was not just camouflage paint or anti-rust coating. It was a liquid shield forged in the fires of war. By 1942, steel and armour plating were being consumed by tanks, warships, and aircraft production. Field engineers, especially in the Pacific and North African theatres, faced a grim problem: how to protect men and materials when steel was impossible to source. Troops relied heavily on wooden trucks, boats and outposts, which splintered dangerously when hit by bullets. To address this, Allied scientists began experimenting with chemical treatments that could harden or toughen wood surfaces. The turning point came when researchers at the U.S. Forest Products Laboratory in Madison, Wisconsin, developed a method to impregnate wood fibers with metallic and mineral compounds, specifically sodium silicate and casein-based binders. When combined in paint or varnish form, these ingredients soak deep into the grain, bonding with cellulose and creating a dense ceramic-like layer once dry. Soldiers and engineers started calling it, well, liquid armour paint. It was never officially listed under that name, but, field manuals mention silicate-treated coatings for ballistic reinforcement. The chemistry was simple but powerful: sodium silicate, often called water glass, hardened wood by filling its pores and turning it into a fire-resistant, shatter-resistant composite. What made this additive revolutionary was its ability to transform wood without heavy machinery or industrial curing. When mixed with standard paint or varnish, the sodium silicate compound would react with carbon dioxide in the air, forming a tough silica crust inside the wooden structure. This crust could deflect small-caliber rounds, absorb shock, and prevent splintering. In real tests, a layer of silicate-treated wood could stop or slow down 9mm rounds that would otherwise penetrate untreated boards. When applied in multiple coats, sometimes up to 5 layers, the wood became dense enough to rival thin steel plating in resistance. Soldiers used it not only for guard posts and ammunition boxes, but even for makeshift vehicle armour on transport trucks. It also resisted fire and rot, two major concerns in humid combat zones like Burma or the Philippines. The coating gave a triple advantage. It hardened wood, reduced flammability, and sealed it against insects and moisture. For engineers in the field, it was, well, a miracle formula that turned whatever material they had into something usable for defense. Using the additive didn't require factory conditions. A simple process could be carried out in workshops or right in the field. First, soldiers mixed standard oil-based or alkyd paint with liquid sodium silicate in roughly equal parts. The mixture was stirred until smooth and applied with a brush or spray onto sanded wood surfaces. After each coat dried, typically within a few hours, they added another layer. The more coats, the more protection. In many cases, they would heat the wood slightly after application using field stoves or sunlight to help the compound set deeper. The result was a hardened surface that felt like stone to the touch. This technique was especially popular among engineers building barricades or reinforcing the undersides of wooden trucks carrying munitions. A few field reports mention British and American engineers using this method on the interior walls of wooden boats and pontoon bridges to resist shrapnel. The principle was the same. The paint wasn't stopping tank shells, but it dramatically reduced splintering and slowed small projectiles that could wound crew members. While we no longer depend on sodium silicate for battlefield defences, the principle remains extremely relevant for survivalists, restorers and builders today. The same liquid glass compound can be purchased in hardware stores under names like water glass or silicate sealer. By mixing it with paint or clear wood finish, one can strengthen wooden sheds, cabins and even outdoor furniture against moisture and fire. For example, if you're building a survival shelter or restoring a vintage military crate, you can recreate the WWII formula by blending 1 part sodium silicate solution with 1 part exterior-grade varnish. Apply it in several layers, letting it dry fully between coats. Once cured, the surface becomes far more resistant to impact, water and decay. For anyone studying or reenacting wartime engineering, this is a living piece of history you can actually use. It's also worth noting that this method has inspired modern composites and protective coatings used in construction and even ballistic panels. The idea that you could take an organic material like wood and chemically reinforce it without melting, forging or laminating was decades ahead of its time. The story of bulletproof wood paint captures the very spirit of World War II ingenuity. Soldiers and scientists weren't waiting for perfect conditions. They built solutions with what they had. It shows that innovation often comes not from abundance, but from necessity. When steel ran out, they turned to chemistry and craftsmanship. Even though the silicate paint additive never became standard military issue, it found its way into countless improvised defences and engineering projects. Today, it stands as a reminder that history's greatest technologies sometimes hide in the simplest forms, like a tin of paint that could stop a bullet. If stories like this fascinate you, the small inventions that changed the tide of war, then you're in the right place. In the Beginning is dedicated to uncovering the forgotten technologies and field solutions that defined human resilience during the toughest times in history. So, if you haven't already, hit subscribe, share this video with a fellow history enthusiast, and help keep these stories alive. Because understanding the past isn't just about what was invented, it's about why it was needed.